ನಮಸ್ಕಾರ ಎಲ್ಲರಿಗೂ. This is Dr. Sharna Mounty, Assistant Professor in Mathematics, Government First Grade College, Jevargi, Kalburgi district. In the Fourier series, we know that there are two kind of intervals. One is a pi kind and one is a L kind. So we know that what is a pi and what is a L. Pi means the presence of the radian term. L means it is a real number. That means we can define it is in the interval -2 to 2, -1 to 1, or 0 to 2, 0 to 1, what it may be. But it is in the form of 0 L comma L, or minus L comma L, or 0 to 2L, as in the radian intervals. In this video we will go for the discussion of the interval which is 0 comma 2L. The Fourier series of the function in the interval 0 comma 2L. Suppose the function f of x is periodic and is defined in the interval 0 comma 2L, where L is a positive number. Then the Fourier series of the function f of x defined in the interval 0 comma 2L and is given by f of x is equal to a0 divided by 2 plus summation n is equal to 1 to infinity an cos n pi x divided by L plus summation n is equal to 1 to infinity bn sin n pi x divided by L. Here the unknown terms are the coefficient constant or the Fourier constant are a0, an and bn. These a0, an and bn we can define according to the intervals 0 comma 2L or minus L comma L. For this interval, that is 0 comma 2L, the a0 value is 1 divided by L integral 0 to 2L f of x dx. An value is equal to 1 divided by L, the integral 0 comma 2L f of x cos n pi x divided by L into dx, and bn value is equal to 1 divided by L integral 0 to 2L f of x sin n pi x divided by L into dx. If we come for the problems for this interval 0 comma 2L, if we given the function f of x is equal to x over the interval 0 comma 10, if it is 0 comma 10 compared to the interval 0 comma 2L, where L which is equal to 5, so that means a0 is equal to, as we know for the formula for a0 is equal to 1 divided by L integral 0 to 2L f of x dx is there. Substitute the values of AL and 2L value. We will get a0 is equal to 1 divided by 5 integral 0 to 10 f of x dx, and equal to 1 divided by 5 integral 0 to 10 x into dx, because f of x they are given is x. On integrating x, that is x square divided by 2 over the interval 0 to 10. Substituting upper limit and lower limit and multiply by 1 by 5, we will get a0 is equal to 10. If we coming for the an values, that is 1 divided by 5 integral 0 to 10 f of x cos n pi x divided by 5 into dx. F of x is equal to x using the by parts or Bernoulli equations over the interval 0 to 10. First function as it is, integration of the second is sin n pi x divided by 5 whole divided by n pi by 5, and the differentiation of x is 1 Again the integration of sin n pi x is minus cos n pi x divided by 5 divided by n pi by 5 whole square. If we taken again the apply the same rule, then the first term differentiation of 1 it will be 0, so that means the higher differentiation and integration will be tends to 0. So for that we have to stop here only, because the differentiation term it tends to the constant value. So apply the upper limit as well as the lower limit. By that we are getting 1 by 5 0 plus 5 square divided by n square plus 5 square, minus of the lower limit it is plus 0 plus 5 square divided by n square pi square. So 0 0 it will cancel, one is a positive and another one is a negative, so that means that also cancel, the whole value is 0, so that means an value is 0. If we coming for the bn value, 1 by 5 0 to 10 f of x sin n pi x divided by 5 into dx, that is a 1 by 5. Again apply the Bernoulli rule, so that means upper limit and lower limit, apply that, and we will get bn value is equal to minus 10 divided by n pi. Substituting the values of a0, an and bn, the integral terms or the coefficient, Fourier series coefficient, substituting the Fourier constant values in the above equation, we get f of x equal to 10 by 2 plus 0 plus summation n is equal to 1 to infinity minus 10 n pi sin n pi x divided by 5, and substitution the summation value, we will get 10 minus 10 by pi sin pi x by 5 plus 1 by 2 sin 2 pi x by 5 plus dash dash. So that is the series is in terms of the pi, sine of pi. The second value it is f of x is equal to 2x minus x square. The same thing here, the L it is in the form of 0 to 2L, so L is equal to 1. Substitution in a0 value, that is equation is a0 f of x is equal to 2x minus x square, so that means a0 value after applying the upper limit as well as the lower limit, it is 4 by 3, and an value is 1 by 1 0 to 2x minus x square cos n pi x dx. Applying the same Bernoulli equation, the an value is after integration and substitution of the lower and upper limit, we will get minus 4 divided by n square pi square, and the bn value is it is 0 I think, because we know that the sine value is that is n pi x is odd or even. Bn is equal to 1 by n 0 to 2, and it will tends to 0 after applying the lower limit and upper limit. Therefore the f of x series is tends to 2x minus x square 2 pi by 3 minus 4 pi square summation n is equal to 1 to infinity 1 by n square cos n pi by x. If you put x is equal to 1, the series is tends to summation n is equal to 1 to infinity minus 1 to the power of n plus 1 divided by n square is equal to pi square divided by 12. These are the some examples related to the interval 0 to 2L. In the same manner we have to solve the examples, and these are the some references.